So today in this class, as we have covered all the 6 distribution, 3 for discrete random variable, another 3 for continuous random variable up to exponential and the uniform one. Here we are going to move on to learn some statistical measures in probability. Okay, after having the basic knowledge of statistical measures in probability, we are going to evaluate these statistical measures for our those specific distributions that we have learned till date, both for discrete as well as for continuous random variable. Okay, so today we are going to learn some statistical measures in probability which will be required to measure, to find out the measures corresponding to particular distribution. Okay, somewhat is known to you and some part is unknown to us. So we will cover some of them at first, the basic idea, and then one by one we will move on to finding these statistical measures for, or rather you can say the value of these statistical measures or expression of these statistical measures for our specific probability distributions. Okay, so let us move on. For that we are on some statistical measures in probability. See, whatever we are going to deal with, we are going to deal with a random variable. Okay, so let capital X be a random variable. Then according to statistics, what is the very first statistical measure that we have learned in our school level also? That is the arithmetic mean. 3 types of mean we have learned: arithmetic mean AM, geometric mean GM, and then the harmonic mean. So here also we are going to evaluate arithmetic mean corresponding to a particular random variable capital X. It is denoted by X bar. And how we are going to evaluate this, we have learned in our previous classes also, or we have evaluated in our previous classes for some specific distributions. That is arithmetic mean. In terms of probability, it is expectation of X. If we are going to evaluate arithmetic mean for a particular random variable, that means we are evaluating expectation of X. Okay. Next is the expression for geometric mean. Look, denoted by capital G, it will be evaluated again in terms of expectation as exponential to the power e to the power expectation of ln x. What is this ln? Ln is natural log. Okay, log is log to the power base 10 and ln is natural log to the power base e. Okay, so exponential to the power expectation ln x. That means if we are going to evaluate this part, first what we are required to find? First we will find ln x and then expectation of ln x, and then we'll take the power of e as expectation of ln x. Okay. Next, harmonic mean. It is the reciprocal of the arithmetic mean or containing the reciprocal of the variable also. Like h, it is denoted as h. It will be evaluated as 1 divided by expectation of 1 by x. This we can evaluate very easily. Okay. So in this way, arithmetic mean, geometric mean, and harmonic mean will be there. Then comes the variance. Variance, we have learned that this also, that it is expectation of x minus ex whole square, or the modified form that we have already utilized, that is expectation of x square minus ex whole square. This we have utilized already in our particular distributions. Okay. Next comes the standard deviation. Standard deviation is what? Denoted by sigma x. If it is for random variable x, it is denoted by sigma x, and it is the positive square root of variance of x. Okay. Next is mean deviation. Deviation from the mean value. It is denoted as md, and it is evaluated at expectation of mod of x minus ex. What is the cx? Cx is the mean value. So how much it is deviated from mean value, that mean deviation is obtained. That is expectation of modulus of x minus ex. Okay. Next is the expression for coefficient of variation. Coefficient of variation for capital X, for the random variable capital X. It is denoted as CV, and it will be evaluated as sigma x divided by x bar into 100%. Coefficient of variance will be there in percentage, so it is 100 into 100. Okay, sigma means standard deviation divided by x bar. X bar means arithmetic mean. So standard deviation divided by arithmetic mean into 100. That will be your coefficient of variation. So these are the basic measures in probability, basic statistical measures in probability that we are going to evaluate for a particular random variable. Okay, so let us take a particular problem and then we are going to evaluate all for this particular problem. See, look at the problem. If x is a random variable with probability function fx equals to 1 by 5. Okay, x is a random variable with probability function fx equals to 1 by 5 for x equals to 1, 2, 3, 4, 5. For only these values of x, our fx is 1 by 5, and for all other values of x, your fx will be equals to 0. Okay, so now we are going to find in this particular problem AM, that means arithmetic mean, geometric mean, harmonic mean, mean deviation, standard deviation, and hence coefficient of variation. Okay, so now first of all you are going to tell me, I am sharing the whiteboard to do the problem, but still first of all you are going to tell me here fx is given to you as 1 by 5. Fx equals to 1 by 5 for some specific values of x, that is x equals to, for x equals to 1, 2, 3, 4, 5. Now can you tell me which type of random variable it is, or which type of random variable we are going to deal with? Is it a case of discrete random variable or it a case of continuous random variable? If you can tell me that, and then I'll proceed. Yes.
Random variable. Discrete random variable.
Shahib, a little louder.
Discrete random variable, ma'am.
Very good. It is a case of discrete random variable because the values of the variable are given to you as some isolated values, some discrete values. Okay, no intermediate values are need to be considered over here. Okay, so this is a case of discrete random variable. Now, the very first thing that I need to obtain from there, that is arithmetic mean. Arithmetic mean means what? What is AM? AM is expectation of x. So AM equals to expectation of x. So expectation of x means how we are going to evaluate. If it is a discrete case, expectation of x will be summation x fx. Summation over all x, sum of all x into fx. What is fx over here? 1 by 5 for x varying from where to where x varies? From 1 to 5. Okay, so 1 by 1, what will I write as expectation? 1 into 1 by 5 plus 2 into 1 by 5. Excuse me for a little bit, right? Sorry for interruption. Okay, then it is 2 into 1 by 5, then 3 into 1 by 5 plus 4 into 1 by 5 and then 5 into 1 by 5. Okay, so this is our expectation of x. This we have already done in our previous classes for some specific distributions also. Okay, so the value which will come out from there, I think 3 will come out. See, 5 will be the denominator, and the 5 plus 4, 9, 10, 11, 12, 13, 14, 15. 15 by 5, so the value will be 3, right? So expectation, that means arithmetic mean will be 3. Now geometric mean. For geometric mean, what is required? Geometric mean G. The expression for this is e to the power expectation of ln x. Expectation of ln x. Ln means natural log or log x, right? So first I require to find out ln expectation of ln x. Expectation of ln x means what it will be? See, the expectation of ln x. How? What will I write according to formula? You can tell me. Summation a summation.
ln x.
Good. Summation ln x into fx. And what is our fx? Fx is again 1 by 5. Okay. So now I'm going to find this summation for x varying from 1 to 5. So what will I write at first? ln 1 into 1 by 5. Similarly, going on like this, I'm not writing each and every term. You can write it ln 1 plus ln 2 plus ln 3 plus up to ln 5 into 1 by 5. From your calculator, you can evaluate this value, and this is your expectation of ln x. Okay. Expectation of, that means it will be log 1, 1 by 5 into log 1 plus log 2 plus log 3, log a plus log b plus log c. What is the formula for log a plus log b?
Log A.
Log ab.
Log AB. So all multiplying this, we will get it as, I think, 120. Look, 5 into 4 into 3 into 2 into 1, you will get it as 120. Right? So this is expectation of ln x. 1 by 5 ln 120. Log of 120. Right? Then what is g then? So expression for g will be e to the power 1 by 5 log or ln 120. You can very well find the values of these utilizing your calculator also. Okay. Achha, so this is your G. Similarly, we can find H. I think H, all of you can find. H is what? 1 by expectation of 1 by x. So first find the expectation of 1 by x. We all can find expectation of 1 by x, and then 1 by of that will gives you the harmonic mean h. Okay. Next is what? Mean deviation. Mean deviation is what? Formula for mean deviation, MD, is expectation of mod x minus expectation of x. Expectation of x we have already got. The value of expectation of x. What is that for this particular problem? What is that? 3. Okay.
3.
So what we can write over here? We can write this as summation mod x minus 3 fx. Fx means again 1 by 5. Okay. So this summation we will do for again x varying from 1 to 3, 4, 5. So we can write it as, for first term, for x equals to 1, it is 1 minus 3, obviously mod into 1 by 5 plus next 2 minus 3 mod value into 1 by 5. Next 3 minus 3, that will be 0. Then 4 minus 3, then 5 minus 3. You can go on like this. The last term will be 5 minus 3 mod into 1 by 5. Whatever the summation value will come out, that will be your mean deviation. Okay. Achha. After mean deviation, what we have? What we require to find out according to the problem? Let us see. Mean deviation, then standard deviation. Standard deviation means what we require to find out? Bolo? Standard deviation means what is required for us?
Variance of extra roots.
Variance. Okay. So variance, square root of the variance. So first we are going to find out variance of x. Variance of x means ex square minus ex whole square. I think you can do it. Ex square minus ex whole square. We all can find the value of ex square, right? And ex is already there with you. That is 3. That is whole square. So find ex square, then minus 3 whole square. So variance done. Then what it is? Standard deviation means variance. You can see the variance will come out for this particular problem is 2. Okay. So what will be your standard deviation? If you can tell me.
Root 2.
Root 2. Good. Positive square root 2. Okay. And coefficient, the last one is coefficient of variation CV. What is that? Sigma x by x bar. Sigma x by x bar. X bar means arithmetic mean into 100%. So what is the CV over here? Sigma x is root 2. And what is x bar? What is x bar? 3. X bar is the arithmetic mean, nothing else. This is your x bar. This is your x bar. Arithmetic mean. It is denoted by x bar. So into 100%. So coefficient of variation is this one. Okay. So in this way, if a particular problem is given to you, first I need to check out whether the problem is for continuous random variable or the problem is for discrete random variable. If it is a discrete one, we will follow the formulas according to the discrete one. If it is for continuous one, we will follow the formula according to the continuous one. Is there any doubt in any step? Just we need to utilize the formula, nothing else. For arithmetic mean, geometric mean, harmonic mean, mean deviation, variance, standard deviation, and coefficient of variance. Is there any doubt? Then I go for the next problem, which is for the continuous one. Is it okay for you all?
Yes.
Yes.
So let us move on for the next one. See the next problem. What it says that if x is a random variable with probability function small x, small fx given by small fx equals to 1 by 3 for x ranging from 0 to 3 and equals to 0 elsewhere. Again, you need to find the same thing: arithmetic mean, geometric mean, harmonic mean, mean deviation, standard deviation, coefficient of variance. Okay. So obviously, this is a problem for continuous random variable. Is there any doubt for that? Because the random variable values are given to you in a particular interval. It can take all values. It can take any value ranging from 0 to 3. Okay. In this interval, it can take any value. And for all other values outside this interval, it will be equals to 0. So utilizing this, we can find now, since it is a case of continuous random variable, simultaneously we will utilize the definitions for continuous random variable. As see, for example, if I going to find arithmetic mean, then what expectation of x, what it will be? Now no more summation will be utilized. It is integral minus infinity to infinity x into fx dx. This is the definition. Now this integral will be splitted out and we will take only the part 0 to 3, because at all other parts the fx value will be equals to 0. So the value 0 will come out. So we will take only the part where fx has a definite value, that is 1 by 3. So it is taken as 0 to 3 x into fx. What is your fx? 1 by 3 dx. Okay. Similarly, expectation of ln x. Again, the integral we are going to utilize an ln x. Now see, one thing you need to check it out over here, that this is ln x and here we are going to evaluate. Ln x means here we have written ln x and into fx. Fx is what? 1 by 3. We are going to evaluate it from 0 to 3. See, this integral does not exist at all. Why? If you can tell me, this integral does not exist at all. Why? Because of this 0. Because of this 0. ln 0 or 1 by x at the point 0 does not exist. So if I evaluate this interval, this does not exist. It will diverges to, the value of this interval diverges to infinity. So this does not exist. So what we will write, that geometric mean is not defined at all. Geometric mean is not defined for this particular value, right? Okay. So similarly, next we are going to find out harmonic mean utilizing the same formula, utilizing the integration. Then comes the mean deviation. Again, utilize the integration. Same concept we are going to follow. Just instead of summation, we are going to utilize integration as we are dealing with the continuous random variable. Is the difference of these two problems clear to all? I have done one discrete random variable problem, one continuous random variable problem. Is the difference clear to all? How we are going to find out the measures? Is there any doubt in any point?
No, ma'am.
Achha. Next part that we need to move on, that is the concept of moments, skewness and kurtosis. Okay. So these three concepts we need to cover out one by one. That one is moment, then skewness, then kurtosis. See, what does these signifies at first? As the mean value, whatever we have found just now, the mean value gives us what? That how the random variable is accumulated in a particular data whichever is given to you. But where is the mean? Where the values of the random variable are accumulated more. Okay. Then what variance will give us? Variance will gives us variance of standard deviation, you can say. That will gives us how the values are deviated from the mean value. How much the other values are deviated from the mean value. That what the mean deviation is also gives us an idea about the scatteredness of the values from the mean value. Okay. Now what? Now two new concepts that we are going to learn now. One is moment, then skewness and kurtosis. Moments gives us an idea, or rather you can say the moments. In moments we will have the skewness also. Moments gives an idea about the symmetry of the values, how symmetrically they are located in a particular graph or in a particular data. Okay. And what about kurtosis? Kurtosis gives us the pickedness of the distribution, how picked, how it will be, how much it is picked in a particular graph of a distribution. Okay. So this you came to know whenever we will do the problems, but moments or skewness gives us the symmetry and kurtosis gives us the pickedness of the distribution. Now one by one we are going to check out the moments and skewness and then kurtosis. These are just formulas, nothing else is there. Okay. Some types of moments and then skewness and kurtosis we will learn. See, the first type of moment that will be there, that is raw moments about origin. The raw moments about origin. It is denoted by alpha 1 or mu 1 dash. Somewhere you will find alpha 1, somewhere you will find mu 1 dash. And it is evaluated as expectation of x. So this is first raw moment. Alpha 1 mu 1 dash means first raw moment. How it is evaluated? Expectation of x. That means what is our first raw moment? Our mean value. Expectation of x is what? Expectation of x is what? Nothing but the mean value as we have just evaluated. So mean is our first raw moment. First raw moment about the origin. Okay. Number 2, second raw moment, that is alpha 2 or mu 2 dash, that is expectation of x square. Similarly, going on like this, rth raw moment will be alpha r or mu r dash, that is expectation of x to the power r. Expectation of x to the power r. All of us, we can evaluate very easily these expectations if the corresponding distribution is given to you. right? So these are all raw moments about origin. Now comes to the raw moments about a particular point A. If a particular point 1, 2, 3, 4, 5, 6, 1.5 is given to you, then about that point it will be modified as first raw moment will be mu1 dash A. It will be evaluated as expectation of x minus A. Similarly, mu2 dash A, expectation of x minus A whole square. It is about origin, so it is x minus 0 you can consider. X minus 0 whole square, so x square. X minus 0, so x. X minus 0 to the power r, so x to the power r. Similarly, instead of 0, now it is instead of origin, now it is the point A. So we are writing it as expectation of x minus A whole square. Mu3 dash will be expectation of x minus A whole cube. And likewise, mu r dash A will be expectation of x minus A to the power r. So this is all about raw moments. Okay. Now come to the next important part, which will be there in your problems in your examination. That is the central moments. Raw moments may also be there as it is related to central moments also. Central moments. Look, only mu1. Now no mu1 dash. It is denoted as mu1. What it is? Expectation of x minus ex. Expectation of x minus ex. That value will always be equals to 0 because it will become expectation of x minus expectation of x. So it will become 0. So first order central moment will always be 0. Second order central moment of order 2, expectation of x minus ex whole square. That is nothing but our variance. We have already learned. Okay, ex minus ex whole square. That is our variance. Mu3, ex minus ex whole cube. Likewise, mu r, ex minus ex to the power r. Okay, so this is the how we can evaluate the central moments in terms of expectations. Now come to the here some raw moment relation between raw moments and central moments are given to you. You can go through it. I'm not going to just read them out. You can go through the formula, everything, the evaluation, the simplification, everything is written over there. You can go through it. So if you see that mu1 is related to mu1 becomes 0, that we have seen. Mu2 is related to mu2 dash and mu1 dash. That means central moments in terms of raw moments. Mu2 dash and mu1 dash is what? Raw moments. Okay. Similarly, mu3, mu3 dash, mu1 dash, mu2 dash. So central moment again related to the raw moments. Similarly, mu4, up to mu4 you learn that much is there for you. Okay. And then comes the skewness and kurtosis. See, skewness, it is the measure of symmetry. Coefficient of skewness will again be in terms of central moments. If you know the central moments, know the formula, we can evaluate it. Similarly, kurtosis, coefficient of kurtosis again in terms of central moments. If you know the central moments, we can evaluate it. So skewness, kurtosis, again we will do it in our next class. Up to the raw moments and central moments, what we have done, that we are going to learn in today's class. Okay.